Well, welcome. My name is Diana Honish-Haig. I'm excited to welcome you all this evening. I get to serve as the Director of Retention and Student Success for all of our online master's degree programs at the University of San Diego. Part of my role is exploring different avenues for students to make sure that their engagement is increased and elevated. And so one of those is engaging with our amazing alumni. So tonight we have with us our inaugural class alumnus, Filipp Kravsovsky. He's going to be facilitating our session. He's a data scientist and software engineer at the private equity alternative investment space with a track record of projects in DevOps, data mining, web apps, and ML with a focus on rapid prototyping and iteration. He's passionate about tutoring and mentoring others and is fluent in Python, SQL, R, VBA, JS, Power BI, Databricks, Azure, and more. He's got experience with Encore Capital Group, Allvue Systems, and currently holds the position of associate with P10 Incorporated. So please join me in welcoming Filipp.
Yeah, thank you for the welcome, Diana. Actually, I just recently got a new gig at a fund accounting shop called Vector, but I was a P10 before that. Forgot to throw that update in there. Well, hi guys. I heard there were going to be 99 of you at some point, so that's exciting. But yeah, so like Diana said, I've mostly been working in the financial space. I think I started out wanting to be more data sciencey and then slowly made the trajectory towards data engineering. But the great thing about the applied data science program at San Diego is that you get a lot of interdisciplinary foundation to kind of go in what direction you want. Professor Tarshizi, which I'm sure some of you guys know, kind of described it as the intersection of like statistics, business analysis and computer science. So you can end up in any three of those domains more so than the other two. I kind of ended up more in the software engineering route, but I would say like you get the foundation to end up in any of those. I know it's a bit of a tough job market right now for data science, just comp sci in general, and what that means for the interview process, and also the way that I designed the slides that we're going to go through is that data scientists are kind of turning into like one-man armies. It's not enough for you to just be able to do ML at this point. Mostly people that are hiring are looking for things like ML ops. So having a basic knowledge of like AWS and Azure and how those things work is starting to become more and more relevant. Like the data engineering portion is becoming more relevant. Your ability to do things where like the deliverable isn't necessarily a model. It might be an API that you have to host online. Like these things are becoming more and more relevant during the interview process, and you will get asked about a lot of those. So before I start sharing slides, this is, I called it the Survivalist Guide to Python, because this is all the stuff that isn't part of the core curriculum for most data science programs that is just going to have to be worth your consideration. The audience for this presentation is people that sort of know Python and haven't dug their heels in yet. So, if this is your first or second year working with Python, what this presentation is meant to do is nudge you in the right direction about concepts to explore outside of the routine. So you guys are probably working with pandas or NumPy. I'm assuming most people are. I see everyone's cameras off, but if I can get a thumbs up from anybody just to confirm you guys are still using pandas, that would be cool. Okay, cool. Matt and Taylor got me. Good stuff, guys. Yeah, a lot of your work will be with that, but increasingly the interview process seems to be focusing on what I call vanilla Python. You'll have a lot of interviews where you cannot use any libraries except what natively comes with Python. So these presentations are mindful of those concepts. I'll go through a couple of interview questions that I've gone through myself. If we have time, maybe I'll do a little answer here and there. I will be sharing a VS Code terminal the entire time. So if you guys have Python installed on your machine, feel free to follow along. And then at the end, we'll do like a Q&A, just literally just ask me whatever you want. How did I end up where I am? Do I have any advice for you guys on what to do, what not to do, both in your grad school program and, in the field when you guys start working. So without further ado, let's party. Okay, so Diana, you can see my screen, right?
Looks good.
Yes. Cool. Okay. So we did this part. All right. Just like I told you, that's what I call the presentation. So let's talk about stuff. So basically a brief remark on what tools and libraries to think about as you start interviewing, looking for work. What should you be good at? You don't need to be good at all of these. Again, like some people are better at some of these things than others. And I think in a time where you can use like Copilot to learn more, and I'm making that caveat because you shouldn't have Copilot doing your homework for you, but it also gives you unfettered access to like the modern Library of Alexandria. So it's a great place to learn new information, to get better at something. But yeah, some libraries, the importance of keeping code pretty. I have a student who developed the motto that like code should be sexy, which is a pretty radical stance, but you know, they get the idea. So the importance of that. We'll talk about the basics like functions, classes. I'll briefly remark on abstract classes, some basic, data storage, data structures like lists, sets, dictionaries, and then we'll go straight into stuff that's interview related and do a bit of an AMA. All right, so as far as libraries, I've mentioned a few of these. For ETL, like obviously NumPy and Pandas, you will be mostly working with data frames. That's the great thing about data science. A lot of your work is fundamentally tabular. There are cases where you'll need to use SQL, but this isn't part of this presentation. For things like dimension reduction, you'll probably be using scikit-learn. That's also true for ML. And then the data engineering portion, and I think this is honestly like the part that you'll have to do the most exploring on your own. BS4, beautiful soup, the Python request library. A big portion of what data scientists do is not actually ML. It's getting data and cleaning it up for the crowd that's doing the modeling. There was this like Food Network documentary about sushi chefs. And now in Japan, they spend their first 10 years just washing the rice. They don't even make the sushi. Data engineering is a lot like that. You know, if the rice is bad, the sushi is not going to taste good. If your data is bad, if you don't know where to get it from, if it's unstructured to the point of not being practical, you can you can throw a billion different random forest variations at it. It's not going to work. For making stuff pretty, I'm more of a back-end crowd kind of guy, so this is less important for me, but Plotly, Matplotlib, Seaborn, just you need to be able to make charts like RFC charts, bar graphs, scatter plots, a lot of those things. For time series analysis, you'll be doing a lot of plotting. This one is less established, I would say, for the data science crowd. At least it was when I was, in my cohort. Streamlit and Gradio are two Python libraries that can let you build a small web app from scratch only using Python. So there's no HTML, there's no JavaScript. They're used by data scientists to prototype and also host their data science projects for free. If you want to demo stuff during interviews, and I highly suggest you do, learn Streamlit. It's really, really easy. We won't have time to do it during this presentation, but I'm not being hyperbolic when I say you can literally launch a website in 3 lines of Python code. Definitely an important skill to have. I think a little overlooked in most data science curriculums, like not necessarily San Diego, just in general. So great tool to have in your back pocket. And then the last ones are the ones you guys probably know about: TensorFlow, PyTorch, Hugging Face for natural language processing. And these are all things you'll have to concern yourself about. These are things that people will ask you about during interviews and what they do. Before I move on, I can take 1 or 2 questions here. Or do we want to save it till the end, Diana? What's your speed?
We don't have any questions that have come through the chat as of right now.
Okay, cool. Well, keep them coming, guys. Okay, so my favorite part, code should be fundamentally pretty. So it's not just about functionality. Code needs to be readable and maintainable. Like most data science students, I know that you know what your code does in the moment, or maybe you don't. Maybe it's a black box that just gets the job done because you copy pasted it from Stack Overflow. The question is, do you know what your code is going to do 3 months from now? Can I hand your code off to somebody else in your cohort and will they know what your code is doing, right? Like these are important questions because one, I've seen projects, not just mine, but those of like people I mentor, pass and fail on readability. Like the bad code can add 10 hours of work because no one knows what's happening in it. So some basic tips here, and we'll do a few examples. Pick a style on your team that addresses a lot of these concerns. How are you naming your variables? Moreover, how are you naming your functions, right? All functions should begin with lowercase names. Also, functions should be named after the thing they do. Like I know a lot of like Python exercises, you know, foo is a function that takes X, bar is a function that calls foo. Like these things don't mean anything. So when you look back at your functions, we can name them for the thing they do. The same for variables. Variables should be more descriptive than less. And wherever you can, comment things, add doc strings, make type hints. These things will save you down the line. So let's do a quick demo. I'm gonna pull up VS Code. One sec. Second function. Okay, yeah. So here's an example. So this is one of those classic ones. Actually, no, that's a bad one. There we go. Okay, cool. So this is an example of a function that calculates a progressive income tax for a given income. So what do we like about this? And again, this is not perfect. There are faults in this code. You know, I encourage you to find them and point them out as practice. You'll also be getting all of these later, hopefully. So the name of the function is exactly what it does. It calculates a progressive income tax. I'm using camel case. My first word is lowercase, everything else is uppercase. You'll also notice I'm doing this, and this is very rare in like, you know, first and second year cohorts. We don't generally give hints about what we want the input to be because Python is dynamic in that regard. But here I'm saying that your income, the income you pass into this function should be a float. It can also be an int. So if I really wanted to be expressive, I could do something like this, right? And I'm also specifying this function is going to output a float. These are hints and they don't often get talked about in DS curriculums, but essentially these are human readable. These put absolutely zero constraints on your function to behave a certain way. So I can still pass in something that's not a float or an integer here. I will get an error, but I'm less likely to do that if when I look at your function, I know what it's asking for, right? So like this is a big help for later. Doc strings are these things. It's triple double quotes, which are essentially comments that are just a little more verbose. Like you'll see when I hover over this function in VS Code, I get a little explanation of what it does. That's what this doc string does. Most modern code editors highly encourage you to make one. And then, you know, things here and there, like modular pieces of logic, I'm using comments to signify what those things are doing. Finally, and I think this one's icing in the cake, you won't always be able to do this, so you may not always need to. I'm also making assertions, and assertions are my way of saying like this function cannot proceed unless something is true. So if you try to give me an income that's less than 0, like -10, this assertion will fail and you're going to get this error message. These are edge cases that I don't think you'll encounter at the more elementary levels of your cohort, but I would say get used to making your code crash on purpose. Like it should fail early rather than later when you're down, you know, down your data pipeline or your ETL pipeline and it crashes then. Like you want to catch errors in logic earlier rather than later. Something to think about. And then just other stylistic minutia, like constants, things that never change should be uppercase. Things that are subject to change should be, you know, lowercase. Here I'm sort of deviating, like where I used camel case here, now I'm using snake case and I have underscores. But these are something, like when I say code should be pretty, this is what I mean, essentially. Like it should be easy to read, as opposed to say something like this, right? Same exact function, does the same exact thing, except now the function name is bad. Some of the constants are abbreviated. These are really hard to interpret. There's no comments. Like if I threw this at you, it would work the same way, but you would have no idea what it was doing. Even worse, by the way, is something like this, right? Where we have 3 different income brackets, and for each one, we're manually adding 4 lines of code. Like this is not sustainable. If you have any sort of scenario where you have 10 of something that need to be repeated like that many times, you cannot keep adding 4 lines of code. Like that's an eyesore. It looks like we have a question. +1 on the catching errors. Is there some companies such as Medics plus the week for these? Okay, yeah, good call, Matt. Yeah, I know it's a weird thing to think about, especially if you're new to programming. Like it was definitely new for me, but deliberately setting up your code to like explode is a concern that I think Python and VBA in particular take into consideration, because Python's a very Zen language. So make errors, make them clear. But yeah, so these are all big no-nos. Review them in the recording later. Let's go back to our slides for a sec. So, yep, that was demo time. Okay, so let's talk about grad school in particular. I already covered a lot of these. These are things I found from personal experience that will save you a lot of time when you're doing group projects. The biggest pet peeve I've seen is 4 different people import pandas in different parts of the same notebook. Don't do that. Have one clear block of import statements at the top of whatever code base you're working on. Also, I know it's hard to get used to it, but start using GitHub for collaboration purposes. What I've seen historically is 4 people slacking the same Jupyter notebook to each other and like in a carousel. Don't do that. It really hurts maintainability. Start using GitHub as soon as possible. But yeah, also same thing I said earlier, like functions should be clear about what they're returning. They should be named after the thing they do. And also, they should be as modular as possible. Functions should be small and do one thing really well. So like what I showed you of that income tax thing was the brackets were hard-coded into the function. Generally speaking, that's bad. You should start relying more on like config files or environment files, something that externalizes preferences in your code. Unfortunately, I won't have time to go over that, but all I'm going to say is that if you can avoid hard coding things in functions and stick them in some sort of environment file, the more the merrier. That's what bigger companies do. And then last one, and this is probably a little more esoteric, you can import stuff into a Jupyter notebook. Like you can create all of your logic in a separate Python file and just import those functions into your Jupyter notebook. So your Jupyter notebook is just pure ML or pure ETL, and you don't have to specify the logic for what you're doing inside of that notebook. You're just taking data and working on it. So this is what engineers call separation of concerns. Try to split your stuff out. Everything should do one thing well. Okay, so for those of you guys that already know how Python works, I think you can tune me out a little bit here. I don't know why you'd want to though. But let's talk about the building blocks of Python functions. So what's a function? I feel like a lot of you guys probably know this. I would define it as any set of logically grouped commands that have repeatable functionality. So I wouldn't make a function unless I need to do something n number of times. I know I'm doing it more than once. I have no idea how many times. I don't want to repeat myself. That's one of the main rules of programming. So I'm creating a function. Much like they are in math, functions can have inputs and outputs. They can also have no outputs. They can also have no inputs, and they can also have neither. So you're probably thinking, what's a function with no inputs or outputs? If you guys have taken intro Python, like hello world is a classic example, because it literally does not do anything. There's no input, there's no out, it just prints hello world. And when I say there's no output, I don't mean stuff doesn't happen. I mean, it does not return a value that can then be assigned to something. So in Python and a lot of other programming languages like Java, C#, we do this thing called altering state, where we modify, like, as it implies, the state of our machine, like what's in memory. Can we add stuff to it? Can we take it away, right? So a function can just alter state without returning any sort of number. So Like if you did X equals hello world, you wouldn't get anything back because hello world just prints hello. It doesn't return anything. Functions can call other functions. That's a big one. And lastly, and this is more obscure, functions can be anonymous. This is what we call lambdas in Python. We'll get to those in a sec. They'll be useful for you guys more so than other computer engineers. I think data scientists use lambdas the most out of any group I've ever met. How do we use functions well? Again, and I cannot keep saying this enough, one function should do one thing. That thing might become more abstract, which is why functions can reference other functions, but it should be named after what it does. And when you can, set clear boundaries on what's okay to pass in. Python will let just about anything slide as long as, like, you know, it's what we call, you know, duck typing. If it looks like a duck, walks like a duck, it's a duck. And I'll show you an example later. More demo time. Okay. Let's talk about functions for a sec. So here is a bunch of different examples, and I realize now the font's kind of small. So that first one is an example of a function with an input and an output. We're passing a name, we're getting out a thing that says hi name. No input. So this is hello world, right? Like we're not passing anything as a parameter, but we're getting hello world out unconditionally. In algebra, this is what's called a constant, like f of x equals 5, basically. You always get 5. Doesn't matter what you put in, you get 5. Functions with no output. So this is what I was mentioning earlier. Printing things and returning them is not the same thing in Python. Like if you're still green to Python, this doesn't give you a value to work with. So if I did something like this, right? If I did a equals hello world void, a would contain nothing. And Python has a way of talking about nothing, by the way. None. And then functions of both, right? So if we wanted to make a function to exponent stuff, right? Like we got a base passed in, we can say that we want a float or an integer. We can have a power that we pass in as a float or an integer. And then we get an output as a result of some mathematical combination of those two things. One last thing about functions, and this goes back to like keeping code pretty and clear to read. You can name your parameters. So when I pass in, like when I call a function like exponent that has 2 arguments, I can actually specify what I want to put in. And the great thing about this is that it lets me go outside of like the order of parameters the function has specified. So the function has base then power, but as long as I'm naming my inputs, I can do power and then base, and Python doesn't really care. It also makes it clear to you and your peers what you're passing in and why. Like just more context, the more the merrier. As far as boundaries that I mentioned earlier, right? I would say where you can start getting comfortable asserting things that should be true by this point, right? So if we had a function that, say, calculates how many characters are in a string, I should assert that the thing I'm passing in is a string, right? And if it's not, I should raise an error. Now, you might be thinking like, okay, but we already said that phrase is a string. Why would we do this again? So again, hints are for people only. Python doesn't care what your hints are. That's why they're hints. This is more just, you know, if a human being was looking at this, it's a little more explicit. As far as anonymous functions, so these are a bit of an edge case in programming that, again, you don't really cover very often, but anonymous functions answer the question, what if I needed a function once? What if it wasn't repeatable functionality? What if I just needed a one-off, right? And so that's what lambdas do. Lambdas are structured like this. You have a lambda, you have some sort of input space, and then you get one line of code to do what you want, right? So essentially all of this is the same exact thing as writing out this, right? They are the same thing. Why would we use a lambda? Just less verbose. The drawback to lambdas is that you only get one line to do everything you want. So if your function takes more than one line, probably don't use a lambda. But where would we? So something like this, right? Like, let's say we have a really rudimentary data frame. And I think I could probably run this actually now that I think about it. Let's go ahead and do that. Please don't crash. We taking our sweet time here. I love it. Okay, while that's running. So let's say we have a list of numbers that we turn into a pandas data frame. Okay, and there we go. And let's say we make a column out of them called num. So right here, right? Let's say we wanted to go through each row and cube that number. We could do an apply function where we take each num value, throw it into a lambda as an input, and then the output is just that number cubed, right? So this is an example of where a throwaway function makes sense, because depending on the ETL process you're using, you're never going to need to do this thing again. Like, you're going to cube this once and you're going to move on with your life, and you'll have a new column and you're just good. So this prevents us from adding more overhead to the code base itself while still accomplishing what we want. The funny part, though, if you go back to the number of characters function that we wrote here, right, is that you can actually, even though you specify like we want phrase to be a string, I can pass in a data frame anyway. Like, I don't care that this says that it's a string. I passed in a data frame that was 7 rows long and I got a response of 7. So that's one of the limitations of Python, I think, like where you'll move on to other languages like Kotlin or C# eventually, maybe, I don't know. But essentially you have less control over what goes into a function in exchange for better readability and simplicity. That's one of the trade-offs that Python offers. Let's go back to the slides for a sec. Okay, let's see. We got anything in the chat? Okay, cool. Classes. This, I'm going to be honest with you, took me a very long time to wrap my head around as a software engineer, more so as a data scientist, because I thought to myself, when on earth am I ever going to need to use classes for anything related to ETL? The problem is that the interview process for a lot of the shops I've done, mostly in finance, by the way, will require an understanding of these things. Chances are when you become a data scientist at a shop or a firm or an org, whatever you want to call it, you're not just doing ML, you're building out an entire infrastructure. Like, they'll bring somebody in who has to build things from scratch. And part of what that means sometimes is building out an API layer of some sort to transmit data. A lot of what you're actually going to be doing is centralizing data. Like, most data scientists I've seen hired do a lot of data mastering, which was when you take like 9-10 different systems and move them all into one warehouse. A good understanding of classes is needed for that, because we need a way to describe the things we're centralizing. Like, if you guys can put something in the comments, like, if, just shout out what industries you guys are in. Like, for instance, I'm in financial services right now. I've been in financial services. Some of you might be in like B2B or e-commerce or nonprofits or whatever. So help me keep this more relevant to y'all. If anyone wants to drop a comment as we go through this. But anyway, so let's talk, okay, media and advertising. So like, okay, biotech, cool. I think for media or advertising, you might have a ton of different CRMs, right? Like, there's HubSpot, Salesforce. A lot of companies use a blend of both, right? We need a way of describing customers. Like, what is a customer? What do we care about for each customer? What fields in common do those CRMs have? Those sorts of things, right? So I'm making a use case for why classes matter here. What is a class in object-oriented programming? Essentially, it's a template for describing the existence of something. Like, it's a logical grouping of different attributes and behaviors that come together to constitute, in programming terms, a single entity that can refer to itself and modify itself during runtime. All things in Python, and I say this with a caveat, like, yes, there's a very academic like counterpoint to this, that not all things, but 99% of things in Python are some sort of class. And that goes for anything. Like, you might think basics like, some, like, all variables are, a Boolean or an integer or a float or a string or whatever, but it goes well beyond that. Like, functions have a class type, lists have a class type, and more often than that, it's not always the same. It's not always the class you think. Like, all lists, for instance, like, yeah, they have a class list. They're also considered iterables, right? Like, that's another class to think about. All functions are a callable class. Like, so these things permeate through all of Python. Anything that you can describe as having a set of common traits that show up over and over again. Chances are there's a class for that. What does that mean in the real world, right? A car could be a type of class, right? What kind of traits would a car class have? The number of doors, the color, the make, the model, the miles per gallon, right? Stuff like that, right? So that's one class. A Toyota could be another class, right? So a Toyota might be a special case of the vehicle class where the make is always Toyota, right? So classes can do what's called inheritance, meaning that you can be multiple things at once, right? For instance, Matt is wearing a hat, so we can say Matt's both in the class person, but also in the class hat wearer, which is a subcategory of person, which is probably the worst example you'll hear from me tonight. The great thing is that classes like functions accept inputs. So we have a way of creating a bunch of different objects with slight variations from each other, but at a fundamental level, they all express the same entity. So for customers, like the name and the email might differ when you're syncing a bunch of CRMs, but they are ultimately all still customers. These have a slightly different naming convention. So classes are uppercase, not all caps, just uppercase. Inheritance will show up in your lifetime. If you guys make your way over to the back end and start working with tools like Fast API and Flask, you'll do what's called ORM, object relation mapping. You will be doing a lot of inheritance there because you'll be essentially building out a layer that exists between your SQL database, which I'm sure you guys have worked with at some point during your cohort, and your application layer, which is all Python. So we need a way of translating Python into SQL, and that's what ORM does, very class heavy. Finally, you'll hear me say this a bajillion times, use doc strings. Always use doc strings, always comment. You will not remember why you built this. You will never remember why you built this. I know that sounds radical, it's true. I looked at my GitHub recently and it terrified me. Let's talk about classes. So here's an example. So let's make a class called vehicle. And by the way, so quirks in Python, if we want to make a class, we use the class keyword. If we want to make a function, we use the def keyword. You also notice I capitalized vehicle. There are some things here that are very technically dry that you're just going to have to think about for this portion of the presentation. It'll become second nature later. So every single class ever, when it creates an object, and I want to make that distinction. So an object is something built using a class template. So if I have a class called vehicle, and then let's say I make a vehicle, right? Something like this, right? I run the vehicle constructor and I put some inputs in here. Car is the object, class is vehicle, and feel free to follow up with me if that gets confusing. But yeah, every single class has what's called a class constructor. This is always called double underscores init. You cannot call it anything else. That's what it is always called. This is reserved in Python. You can do horrible things to Python to change this. Don't. And this is philosophically where I think classes started to get to me. The self keyword. What does self mean? If you guys have any experience with JavaScript, it's kind of like this, like this keyword. It's a way of being self-referential. So this is the object talking about itself. You can't pass this in as an argument, like when you create an object of class vehicle, but it needs to be here for your function to work. It's essentially saying that this function is allowed to reference the entity itself in some way. So these are all parameters, right? And I'll show you in a minute, like color, make, model, MPG, things we're interested in. But when we pass them into our constructor, you'll notice the only thing I'm doing with these four is doing self.color equals color, self.make equals make, etc. What does this mean? This means that these are no longer just variables floating around in memory, but rather that these are now variables that are part of the object itself, like they are inseparable, right? So like, I think a good way of thinking about this is rather than hat, it's now a hat that distinctly is part of Matt's body, which is a weird way to think about it, but nevertheless a good example for understanding classes. Like this isn't hat in the ether, this is hat that goes on Matt's head. And when you talk about Matt, you can talk about his hat as opposed to just some hat. So that's what classes do. Classes can also store not just attributes, but also methods or functions. For instance, if I wanted to make a function that describes the car I made to me, I can have this thing, right, that takes all of the things I know about the car, that I know about myself, and combine them into a little string that tells me, you know, what color, what make, what model, how much miles per gallon I get. You'll notice, however, that in this function, I'm not passing any of these things in. I'm just passing in self. So it's a very philosophically ambiguous concept to struggle with at first. Essentially, the only thing I need for a function to talk about itself is the recognition that it's allowed to. So self is the only parameter that gets passed in. And mind you, not by me when I'm calling the function. Like when I call this function, I'm doing this. I'm doing vehicle.self, or sorry, my bad. Vehicle.summary, but I don't need to pass in self. I just need to let the function itself know implicitly it's allowed to be self-referential. And then all of these traits just get pulled in naturally. I don't have to specify them each time. This is one of the good things about classes. They make combining different groups of information really, really easy, especially if you have like a bajillion different class properties. However, I can also have functions that reference both my object and some external data. Like for instance, if I made a vehicle and I needed to know how many gallons I need with that vehicle to make a trip of some amount of miles, like say 1,000 miles, right? I can pass in 1,000 miles as an input. And then with a combination of that and the miles per gallon of this car, figure out how many gallons I'm going to need, right? So if I get 80 miles to the gallon, maybe I'm in a Prius, and my trip is 80 miles, this is going to return 1. So functions can both reference innate properties of the class they belong to, but also external stuff. Like I said earlier, sometimes functions can offer no output at all. They can just do what we call altering state. So because we have a good way of talking about a class, we can do something like this, like let's repaint the car. I have a blue Prius. I say I want it to be aubergine because that's, you know, it's the color people have for their Priuses, right? Aubergine or eggplant, whatever. I pass in eggplant. I want to make sure that the color I'm passing in isn't the one I already have. And then you'll see self.color is now being assigned the value that I gave it. So essentially we're altering the object itself. We're altering one of the properties. So I think I've settled on Matt's hat as a fantastic example at this point. If I ran this function on Matt's hat and I passed in color equals red, it would still be Matt's hat, except now the color of it would be red. The rest of Matt is unchanged. It's still the same Matt, but one of the underlying properties of Matt is now a different color. So there's no output there, right? Like Matt's not giving me anything in return. I'm giving Matt a color. Matt has altered himself accordingly, and I receive no output. I'm just doing it for the love of the game. Let's talk about inheritance for a sec. Some classes can be other classes. So I've made a class called vehicle, and actually maybe we can, yeah, let's run this down here, I think, before we get to the other one. So I'm making a vehicle called a black Toyota Camry, right? Like I'm specifying that it's a black Toyota Camry, miles to the gallon. I don't know. And so I'm going to do 3 things to it. I'm going to print out a summary of it. I'm going to print out its color. I'm going to repaint it to aubergine. And then I'm going to print the color again. And for your eyes only, I'm going to uncomment this. So let's see what we get. Cool. There we go. I'm getting a black Toyota Camry. Exactly what I thought. It was black. Now it's aubergine, right? So this is how easy it is to use classes. And a couple of things you'll note here. So this is my constructor. And like I said, even though summary takes a self keyword, I'm not passing it here. I don't need to. It's implied in the structure of the function itself. For properties, things that aren't callable, I'm just doing Camry.color as if it was a trait, right? So that's how we reference properties and functions when it comes to classes. You're doing object.property if you want something that isn't a function necessarily, just like a trait, like hair color, age. And then object.method is a callable, which means we add parentheses because it's instructions on how to do something. They're just logically connected to that particular class. But like I said, some classes can inherit from other classes. Like a Honda is a type of vehicle. That makes sense, right? So if we wanted to do what's called inheritance, which is essentially that I'm grabbing the properties of some parent class without having to specify them again, right? So Matt, as a hat wearer, also has all of the innate properties of a human being. And when I talk about Matt, I don't need to repeat those properties twice because I've said like, yeah, Matt is a person. He's also a guy who has a hat, right? All of the stuff a non-hat user, it's crazy, a non-hat user can do, like walk and yell, Matt can also do despite wearing a hat. So for Hondas, let's say we do the same thing, right? We have all of the same properties of a vehicle, like color, model, MPG, all-wheel drive. The make is going to be Honda forever because it's a Honda, but maybe we also want to include all-wheel drive, right? So not all vehicles discuss this option, but maybe Hondas have all-wheel drive or, you know, some other sort of setting, which isn't necessarily true for like a Model T Ford, which didn't think about that concept at all, right? So if you're gonna do inheritance, it'll save you a lot of lines of code. The complicated part is that when you initialize an inherited class, or what's called like a child class, you also sometimes need to run the constructor of the parent class. So we can talk about the parent of the Honda class, which is the vehicle class. These aren't objects, by the way. Like this is us saying that a Honda has the innate properties of a vehicle. And when we create a Honda, the super or the parent class, and this will be in the notes later, should also be called. So we're initializing this as if it was a vehicle object first. We're passing in all of these properties. We're hard coding the make as Honda. And then we're also going a step further and doing the construction for a Honda specifically. So vehicles won't have all-wheel drive, but all Hondas will. Hondas will also have all of the properties of a vehicle. And so I might have some other functions like adding a radio, right? So now we have a radio in this thing. Maybe we want to do maintenance work, which is both repainting and adding a radio. You'll notice that I didn't add a repaint function in here, but I don't need to. That's the thing, right? Because we declared that function in vehicle and we inherit from vehicle, I don't have to specify repaint anymore because it's implied. And we'll talk about this later, but generally speaking, you want to consider being able to turn objects into dictionary representations of themselves. We'll get to that in a sec. But let's make a Honda. So I'm going to nuke this for a sec. Let's just run this. Okay. So this type portion, we haven't talked about this yet, but if you ever want to know what class something is, use the type indicator. It'll tell you right away. Also, we might have to speed ahead on this one, but yeah, like we know we're driving a Honda. The summary function, which again, we did not specifically like, you know, explicitly add to the class, still works fine because it's inherited. The add radio thing still works. That was new for us. And then to dict just creates a dictionary representation of the class. So inheritance and classes are going to be super important. We'll go over a couple of different interview questions where they become relevant. I don't expect you to know how classes work by the end of this presentation, but I expect you essentially to just start thinking about them and where they might fit. So without further ado, okay, we already talked about this. You guys think classes are cool. We don't need to do a defense here. Okay, I'll save this because you guys already have the slides, but just some quirks about the nature of constructing objects from classes. You guys can revisit that on your own time. There is also a thing called abstract classes, which are essentially always parent classes, and they don't have any methods or properties, but they're essentially a blueprint for creating classes that say, like, when you make a class with this abstract type, it needs to implement the following functions. So like an abstract class is abstract because it'll say like, you need to have a function called summary. And if you don't, you're not allowed to make this class, but I'm not going to tell you what to put in it. Just you need to have it. Those are very obscure. If we have time at the end, we'll talk about them later. For the first few years, you're probably not going to have to think about these. Okay, let's talk about some basic data structures real quick. There's lists, sets, and dictionaries. You'll notice I haven't mentioned tuples. That's okay. We don't really need to. Chances are if you're using tuples, you have your own reasons for it. These are the more commonly used ones. Lists. Lists are denoted by square brackets. You've seen them in Python. They're great for storing raw data points where we don't care about duplicates or anything like that. They're also indexed, so we have a way of referencing each element. Sets are unique collections of elements that cannot have any dupes. Really, really good for deduping. They can, like lists, be mutated, which means we can add and remove stuff from them. And they're denoted by curly braces, which is kind of confusing because that's what dictionaries do as well. We cannot individually inspect elements of a set, but we can loop through them. I mean, you can, but it's difficult. Looping is ideal. And then dictionaries are what's called hash maps. In other programming languages, there's kind of a meme about tech interviews where if you don't know what you're doing, use a hash map. It's kind of a joke, but like 80% of the time that might actually help you. But it's essentially a way of mapping some volume of information, like any value at all. Whatever you can stuff into a variable, you can add as a value to a key of some sort. So you might have a list of phone numbers, right? So Philip might be the key, and then my phone number, which none of you are getting, would be the value. Same thing for Diana, same thing for Darius, right? And we can store all of these in one data structure. When you saw that to dict function for that Honda class, that's essentially what a dictionary is. Like there's a unique number of keys. You can't have more than one instance of the key, but it's a good way of logically grouping named attributes or information together. So they're kind of like a proto class, if you will. Demo time. And again, if you have questions, please throw them in the comments. I will go fast because this is being recorded. All right, lists. So let's talk about lists. So I have a list of names here, right? Just 4 people. I can name them one by one, right? So I can take name 0. By the way, lists are indexed from 0. So John is actually element 0, Ibrahim is 1, Philip is 2, Diana is 3. It's not 1, 2, 3, 4. If you guys are learning R in your program, throw this out the window. R does index from 1. That was a big pain point when transitioning from one to the other. We can also reference these things in a range, right? Like let's say we wanted the first 2 names, right? We can do 0 to 2. So that lets us reference multiple elements of a list simultaneously, or we can loop through every single element and print it out. So let's do that, right? Let's run this for a sec. Right, so these are my outputs. So this is the first one where I just get John, then I get John and Ibrahim, like 0 through 2, and then I'm just looping through each name and printing it out line by line. So many different ways to deal with lists. Why do we care about lists? What actual use case do they have in data science? And the real answer to that, I found, is that when you're creating Jupyter notebooks, you're going to have a lot of different functions that you want to apply over and over and over again to something, right? So like a data set where each data point steps through these 3 functions. What is and maybe the nature and maybe the number of functions changes, right? Maybe your pipeline is for the cleanup process, there's 20 different functions we run on every single data point. How do we express that elegantly? And the answer is you use a list. So functions, despite being like not really a data point, but more of a blueprint or an instruction, are still variables. They can still be referenced, right? And so what I'm doing here is I have 3 functions that trim some text, replace a pound sign, get rid of punctuation, and I can stick them into a list. There's no rule that says I can't do this, which is a healthy way to explore Python, by the way. Like if you can't think of an abject reason for why logically it shouldn't work, do it. That's how you learn Python. There's no rules to break necessarily, just get weird with it. But like I have a list of 3 different functions, and here's the great part, right? When I loop over them, this is my favorite part, right? I'm using a surrogate variable for all of these elements, right? Like so func is a stand-in for any of these functions. I can call the surrogate, right? Because I know all 3 of these are callable. So I can treat this as a function. Which function? It doesn't matter because it's going to be every function that's in here. I know it's a bit of an abstract concept, right? But like, let's take some data and we're just going to go through each of these data points and we're going to apply all 3 of these functions. You'll notice like we have a function that just consolidates these 3 and applies them all on some given input. If we scroll down, so this is our original data. this is our data that's been cleaned, right? So we got rid of the pound signs, we got rid of some punctuation. So instead of hello pound sign world, we just have hello world. So list comprehension is really good, or I guess like lists are good for ETL pipelines. They're also just good for storing a lot of unstructured data. Like you'll notice, for instance, this is just kind of whatever. A lot of your raw data will be in lists before it makes its way over to like a SQL table or something. So really, really good for cleanup. Let's talk about the other two real quick. As far as sets, I have found very limited use for these, but they do matter. How do we make sets? We either use curly braces and just list a bunch of things out the way we would in a list, or we specify by wrapping a set operator around an actual list. If I wanted to print some of these, this is kind of my only option, functionally speaking. What are sets actually good for? Let's say you have a list of a bunch of duplicates and you're just interested in the unique values. So only A, B, and C, this doesn't count because it's not unique. You could do the following, right? Like you could pass this list in to the set operator, right? Turn it into a set, and then to make it usable again, turn it back into a list. So the only use I found for sets is if you want a list of unique things. That being said, you can also just use NumPy. There's very, very limited use for these. Dictionaries are the important ones. So you'll notice that when we have dictionaries also denoted by curly braces, so this is our key, right? Like name, John, age, 35, state, California. And I'm not going to get weird here, but you can also add a function as a value. Like you should think of functions as variables. They are pieces of data. They are objects. And if they're objects, that means you can stick them in a value somewhere. But these are better than a list, right? Because now I know what each piece of information is. Take the alternative, right? We could do this, right? The problem, unfortunately, is that taken out of context, we have no idea what information this is telling us. Like, yeah, I can probably surmise this is name. What's 35? What's CA? What's say hello? Like, what are these things? Dictionaries give us context as well as efficient storage, right? So hash maps are really, really fast for pulling up information, but it's also a way of elegantly expressing some information. Why do we want dictionaries? Again, I think two main use cases before we get to those. If you want to reference a specific key in a dictionary, and you can only do one at a time, person, open curly bracket, brackets, and then the name of the key. The safest way, at the expense of being a little more verbose, is dictionary.get the name of the key, and then some sort of alternate value if that key doesn't exist. This is essentially a way of saying, give me first name from this list of keys, but if you don't have it, give me none. Alternatively, if we did this, this would cause an error and your code would crash. So I said earlier, you should crash quickly. There are some places where you need to crash and move on, two different paradigms. Like if we don't have a key, we don't have a key, data is fundamentally unstructured. Focusing on making your code be able to move past minor road bumps is also crucial because then you don't have to manually edit your data. But let's talk about use cases. A big one, and you guys can reproduce this yourselves actually, is you will be working with APIs. You will be scraping things nonstop. Being able to send a dictionary as a payload to some API saying like, you know, here's this thing I have, I'm going to send it to some service or third party. It's going to do something to it and give me a response back is crucial for your career as a data engineer. So if we run this output right here, this dictionary is actually a JSON response, which Python turns into a dictionary. When you work with APIs, when you work with scraping, you will be using dictionaries a ton. Okay, and we can cover that, later. So there are two questions that I have ready. There is a hard one and there is a medium one. I did not do an easy one because that would be a waste of your time. I cannot cover both of these because we have 5 minutes left and we're already about to be over time. I have included code for how to solve both of these, but I think the point to make here, and we can go into the solutions if you guys want, like I do have solutions for both if you want to talk about that. There's also a meme about like, companies asking you to invert a binary tree or get the length of a binary tree. And your first thought might be, what on earth does this have to do with data science? And the answer is nothing at all. Most of the time, right? You will be using Databricks or some other tool like DBT, and you just do not have to think about this. And I would say there's a couple of reasons you'll get questions like this. The company you're hiring that's hiring you may not, like, the person doing the interview may not be a data scientist, right? They probably went on Lead Code and looked up Python interview questions and then threw the hardest thing at you. And they realized that as they're not a Python developer, they don't know that this isn't domain specific and that you've never had to do this. Unfortunately, the way the market is going for finding jobs for data scientists, this is just something we have to cope with. This is a problem that can only be solved through two concepts, one of which we didn't cover, creating objects and also recursion. So I'll briefly show you the solution, but I'm not even going to talk about it. This is the solution. When I did the interview, I couldn't get it right. I had to spend like 4 hours after the fact, and then I emailed them and said like, hey, I finally got the solution. I know the interview's over. And they're like, honestly, like, respect for trying. But yeah, like sometimes the hard interview questions aren't verbose. They just take a lot of thinking, right? So I have a class called Node, and it has 2 children. And you guessed it, those children are also going to be nodes. So that's what a binary tree is. If you haven't seen it, unfortunately, we won't cover it later. The other one I think is a little bit more related, but still less so. Like, say we have a bunch of data about athletes, right? Like their age, their height, their rank, whatever. And we want to sort by one of these, right? So if K is 1, we want to sort by age. If K is 0, we want to sort by rank. If K is 2, we want to sort by height. And you'll get questions where it's like, we don't know how many different attributes they have. They might have 10, they might have 1,000. We don't know what K is going to be. It might be like 5, 73, right? That kind of thing. So given uncertainty about what those values are, create a function that sorts a bunch of athlete data and then prints it out given those 2 inputs. Again, is this data science related? Is it ML? No. Is it data engineering? I would go as far as to say not necessarily, but it demonstrates a fundamental understanding of Python, which I think is what the focus is on more these days, because when you get interviewed as a data scientist, you're not just being evaluated on your ability to do machine learning. You're also getting evaluated as like a Swiss Army knife. Like, okay, you can run like a random forest or logistic regression. Can you build an API that gives us the data to run that regression? Can you create some sort of environment that aggregates data so that we can run a random forest? Like, these are the things you'll increasingly have to confront. Outside of these things, what else matters? So big power move, when I mentioned Streamlit earlier, the ability to demo something you've worked on in your interviews is what helps you be memorable, right? Because everyone can talk about their work experience. And I think it's fundamentally a low trust exercise. Like, if you guys have seen those LinkedIn memes, like, how would a LinkedIn recruiter describe a guy that was a car mechanic, not even a car mechanic, like a coffee person at the company, like facilitated cross-functional collaboration between caffeine consumption markets. Like, no, you got coffee. So to an extent, what really matters is you having concrete proof that you did something real that you mentioned on your resume. 2 ways to do this. 1, polish your GitHub. Make repos public. Do not make all repos public. Some repos are bad and should be private, just like little prototypes here and there. But the ones you do make public, have a README file. We can pull up my GitHub if you guys want. I don't think you guys have my GitHub. I'll drop it later. But READMEs, because the people looking at your GitHub, and they will be looking, are not going through your code line by line. They want pictures, like the prettiest possible version. And that's also true for like me when I'm shopping around for libraries on GitHub. If you have a well put together README, I inherently trust you. Another leg up in the interview process, I would say, is being good at documentation. Like, I cannot state enough how many interviews the people I mentor have been able to ace because they said, I love writing READMEs. I'm really good at tracking things and writing stuff down. I'm good at filling out Jira tickets. Like, most companies would rather take an engineer that goes a little slower, but their work is maintainable and understandable, than somebody who goes fast and builds black boxes that fall apart the minute they leave the company. So aligning with a company's like long-term goals is a great way to get noticed as a data scientist. And then, like I said, learn Streamlit if you want to demo stuff. No one's going to look at your, your API or your Jupyter notebook, maybe, right? But having like a small web app is a really, really great way to show a non-technical person, and many of your recruiters will be that. I'll get you in a sec, Max. Something that's pretty and flashy that shows you know your stuff. What's up, Max?
Can you show us what extensions you're using for Python in VS Code?
Yeah. So I don't have a ton going on. I do have a lot going on. Okay, a lot of these are just different themes that I have strong feelings about. So I have Python environments. Let's see. I have Pylance. You won't need Pylance for this stuff that I'm covering here. I also have the Python language support, Python debugger. Yeah, so those four I would say matter the most. And then, if you're cool, the Dracula theme.
Thanks.
Yeah.
So what does Pylance do? Is it like Python language support for VS Code from Microsoft?
No, Pylance is a whole different domain of Python that we could spend forever talking about. So Pylance is a library that helps with object relational mapping, which is essentially answering a whole new question we haven't discussed, which is like, let's say I built out an app with Python, like a backend layer, some sort of API, right? I don't know. So like a weather API, whatever, or some sort of CRM, whatever. How do I turn SQL data into a Python object, right? And I mean that very particularly, like something that I can declare in Python as a specific object type. So like, let's go back here, right? Maybe I have a bunch of vehicles, right? I run a car dealership and I store all of my car data in a SQL database. SQL doesn't have classes. It just has rows of data. That data might have data types, but the concept of classes and object-oriented programming in SQL doesn't really exist functionally. Like that's not what SQL is for. So an ORM layer, and this is where Pylance comes in, makes sure that when you grab something from SQL and bring it into your backend, which is written in Python, that there's nothing lost in translation and you get perfect like data integrity. I don't think ORM will be covered in your guys' curriculum. If you want to start learning about ORM, any of the big three for Python work. So Django, FastAPI, and Flask are all backend frameworks that support ORM. It's easier than you think, but I would say learn SQL before you get into it because, it's easy to get overwhelmed. But definitely a great skill to have for a data engineer.
Okay, that makes sense.
Yeah.
Thank you.
Yeah. And I'm about to wrap up here, actually. I think that was all I had. Yeah, those were that's the end of the slides. So takeaways, like if I had to distill this into one or two sentences, learn about classes, make your code pretty, write good readmes, comment everything. You will be interviewed on things that are not ML related, but are just Python innate, Python specific. Sometimes you will have interviews where you will not have access to like the libraries that make your life easy, like NumPy. In those instances, having a good understanding of different data structures like dictionaries, lists, having a good understanding of functions and how to write them properly and how to make them return things, having a good understanding of building classes that inherit from one another and are self-referential. These are the things that give you a leg up as a data scientist outside of knowing Jupyter and NumPy and Matplotlib and throwing a Hugging Face model at everything until it works. This is my experience. There are other people from my cohort that have gone through things differently. I'll be honest with you, I veered more towards data engineering towards the tail end of my academic career. So I know how ML works. It is not my strong suit, but I have I could keep up with an ML person. It's not my favorite thing to do. I'm mostly veered towards like backend engineering and APIs. That's what I had. If you guys have questions about literally anything, like there are no rules, ask me anything you want. I would appreciate that. But yeah, thank you for having me.
Thank you so much, Philip. That's amazing. Thank you for sharing your expertise. I have shared your LinkedIn. That was by request in the chat. So you might
Cool.
get some some requests coming into you.
Oh yeah, let me give you guys my GitHub actually, now that I think about it. I'm not going to like tout my GitHub as the end all be all of what a GitHub should look like. But there are a few readmes in there. There's a couple of projects I've worked on that I think you guys will find useful. Yes, I can pull that up.
While you're pulling that up, Larry had a question in the chat. How many years have you been coding?
How many years? Okay, so this one's hard to answer. I think the question is, how many years have you been coding, like, well? So I started back in 2017, and my first language was Visual Basic, which is a terrible language that no one should use. But I think it's kind of like how Bruce Lee said, like, there's form and there's substance. And for a while you focus on form and eventually you get to substance. I would say coding in a language like VBA makes you thankful for Python because it has even fewer guardrails and it's very conducive to terrible code. But I picked up Python back in, I don't know, 2018, 2019. I'd say probably closer to 2019. And then I've been, using it professionally since 2020. But all in all, about 7 years, give or take, 7 or 8. GitHub, I found it. So let's see. So I'm going to drop my GitHub in the chat. Feel free to take a peek. I've been a little dormant lately because I got a new job. So all the stuff that I can commit is private. But yeah, guys, other stuff you want to pick my brain about, what not to do, any mistakes I've made that I regret, stuff like that. There's there's all, like I said, there's no rules.
I had another question. Do you recommend any? So I'm from a type safe background, so Python drives me nuts because there's no type checking.
Yes.
What would you recommend, or are you aware of anything that exists that solves that problem, or is it just
yeah so like I think I mentioned this earlier, like working with Python makes you, like, eventually all the criticisms you find in Python end up leading you back to a type safe language, so like you evolve back out into like C# or something. But there are libraries that do enforce type checking. Another good thing is that when working with Pylance or any other ORM library, let me see which one I used for the Fast API. Oh yeah, I think it was like it was SQL Alchemy and Pylance, those libraries. So only at the ORM layer, when you try to create an object that has an ORM specification, they will stop you if you have an invalid data type. So, you can throw whatever you want in there, but it'll be rejected when it uploads to your SQL database. So there's one layer there, but for the most part, yeah, you're right. Python does not have type safety. I forgot what library does have type safety. Like, I mean, I could probably Google it now, but it's,
I think I've heard about
yeah.
Pydantic, but I think it's just for like it's just for data schemas like web requests or something.
Oh, actually, sorry, now that you mention it, I think I had Pylance and Pydantic screwed up. Yeah. I always get those two confused. Pylance is language support. Yeah. So
okay. So what you were talking about was Pydantic.
Yeah. Sorry. I was talking about Pydantic the whole time. My bad. I always mess those up because they both start with Py. But yes, Pylance is the one that like makes your code easier to read in VS Code and like, helps you reference functions across different files. Pydantic is the one that does all that stuff. Yeah, and you'll be using Pydantic for ORM in conjunction with SQL Alchemy. Sorry about that mix-up, guys. Slip of the tongue.
That's fine. Thank you.
Yeah. Yeah, good questions. Max is killing it. Matt, sorry about dragging it out about your hat for so long. Hopefully we're still cool. Okay.
Fantastic. Well, I'll make sure that everyone here receives the slide deck tonight, the recording, Philipp's GitHub and LinkedIn. And feel free to reach out if you do have any follow-up questions. Thank you all for joining us this evening.
Thank you, guys.